I like how coaches sit down. Oh, 42, say Mike.
No.
Canvas was not.
I know.
No.
They were Panthers fans. So I was just like, oh, I can hear the heart.
Yeah, she's texting me.
She's in there?
That's
Does she see the bell?
She gave me a C.
Is she on her phone or her computer?
I don't know. I just texted Casey like a live.
She has a tablet. Unless I can give her the key to my house. She can have it.
Did you watch the football game last night?
Thanks.
Sounds like we're finished?
It looks like a golf.
In 10?
What kind of sports do you watch? What kind of sports do you watch?
Soccer.
Told you. You look like a golfer person.
I can't stand golf.
You
I
just,
can't watch it for nothing.
How about
you just look like
I was getting excited and I started watching the game again last night and I'm like rooting for the Cards and then I'm like,
Oh my God.
so I quit again. I'm so done with American,
sports?
well not Americans because they play soccer here now too, but I'm done with football, I'm done with basketball,
Why
I'm
are you
done
done with
with
basketball?
hockey, all of them. Just soccer. Worldwide sports.
The answer's like,
Okay, sounds like we're done here. Thank you. Homework should have already been turned in as well if you had any.
oh wait.
I thought it was due last night.
yeah, but without from our paper.
Yeah. Wait.
I didn't know we had to.
You know what? I'll leave it on the way out. You guys can turn it in. You guys are supposed to be turning in first thing. I'm starting to feel like that's a little redundant though. Yeah, you turned it in there, right?
You said you're gonna cry and listen back.
Thank you. Thank you, thank you, thank you.
And I would ask her using computer.
Try to go to my website. And then go from there and then look for the
You were saying how white people were so ugly, then you walked by. Ugly. You called you were saying how white and then as he said that, you walked by.
yeah. Just stream it on my website.
Like a bunch of white people.
So yeah, she goes to, she hits a little video icon, a little film strip. Go there and then just push play. Alright, thank you. Thank you very mucho. Silento, please. Silento. Which is gracious. Alright, so. The question was here, do the two images have the same volume by Cavalieri? And then I wanted you to explain. So I want to hear from, I don't really hear much from DeAndre. It's always you, it's never you, that's why I'm calling. Oh, you always get called? Okay, I don't want to be that teacher then. So, Mr. Rice, what'd you come up with, brother? Just because they don't have the same bases, and it doesn't apply.
They also all want the same shape.
Does the shape matter?
Well, it's because they don't have the same base area.
Okay, and again, I need to make sure that I clear this up, okay? There's two parts to Cavalieri, okay? One, they have to have the same height. They have to have the same height. And the reason for that is because if they have the same height, then you've assured that they have the same number of cross sections. Okay, that's the first thing. If they have different heights, then one's gonna have more cross sections than another, right? So height is the first key, and it has to have the same number of cross sections. The second part is that every single one of those cross sections, parallel to the other, has to have the same area as well. So if I cut this way, then this cross section has to have the same area as that cross section. Okay? The shape has nothing to do with it. As long as those areas are equal, then via Cavalieri, then they would have the same areas. But I gave you the answers here, guys. The area of the base there is how much? Over here it's, even if I took 4 times pi, I'm not going to get near 16. So if the bases aren't the same, then that's already one of the cross sections that do not equal each other. Okay? Now, the only thing that happens at this point is that this starts to decrease proportionally, doesn't it? At a rate of 1/3, it just starts trying to dip. So that means that this is going to get smaller as you go. Shape has nothing to do with Cavalieri. The only two requirements is that they have the same height and that every single cross section has the same area. So the cross section that lives here is the same as the one that lives there. Area that's here, the same as the area that's there. So every single point. Now, can I ask you to compare, let's take this cone to this cylinder. Can I use Cavalieri to prove that these are the same, if they have the same height? Because here's the idea. Don't they still have the same base? But that's what you guys have been saying, right? They're the same height, same area of the base. Right, so what we're saying is that every single cross section has to have the same area. So if I cut here, obviously that area is not going to equal this area, is it? It has to be at every single point. Understand? And they'll tell you that sometimes. Hey, you know what? The areas at every cross section are equal, so blah, blah, blah. And then you can answer that. Okay? So for this one, the last one we just did, that's a big no-no. Something like this would be a no-no. You're not feeling so well down here? Sound like you have a cold or some allergies going on. Yeah. Which one? Which one? Sad. I'm sad for you. Because I struggle with allergies and they make me mad. Okay, cool. So questions on the bell work?
So is it the cross section area? Or is it like, well, how do you word it? Is that enough?
One, they have to have the same height. Okay. So the heights need to be the same. Okay? And then every single cross section that is parallel to the other has to have the same area as well. So even when you think about it, when you get to the point there, aren't they just going to be an area of 1? Yeah. So there you go. Elroy, you want to share that with us so we can participate too in your hilariousness? Then cease and desist, sir. What, Devin?
What does desist mean?
Cease and desist.
Yeah, what does that mean? Like, I know
That means
means
stop.
So does desist mean stop?
I don't know. Cease. Now you're gonna make me think about it, aren't you?
Yeah.
Sure. And desist. Way to take that conversation a whole different way.
Can I look it up?
No, don't look it up. Look it down. Stop and quit. Cease means stop, and desist means quit. So yes, it is redundant. What does redundant mean?
I don't know.
You know when you hit your side?
No, I'm just thinking what he's gonna ask next already. You're fired. All right, anyways. It's a short class. I want to make sure I get your questions answered from the homework. I know there was a few, so ask away. Let's go in order because I don't want to jump around. Jump up and get down. Uno. Anybody?
No.
Dos?
No.
Tresemme.
No.
Dylan? Come sit right here on this couch.
Did you say Dylan?
Yes, that's your new name. Right here, Dylan.
She's a dude.
Yes.
It's Dylan's or Taco Lot.
It's not working.
I think I just overthink.
Talk to the couch.
I thought you meant
I feel like he's gonna fall asleep.
Number 3.
No.
Well, you know what? At least he'd be quiet.
Unless he's
It is quiet, actually. No questions on 3?
No.
4?
No.
5.
Yes. Yes. To me.
Okay, 5 says, via Cavalieri's principle, the right triangular prism and the right rectangular prisms have the same volume. If the center plane intersects, so if they cut those two pieces there that are parallel to each other, which of those would be the height and the base for this triangle? Just a question. Well, that means that if I took the base times the height, that's not a height at all, times the height divided by 2, that should equal 8 times 6, correct?
Yeah.
So, what is 8 times 6? 48. So, let's take a look at these options here. If I take half of 12, I'm going to get 6, aren't I? 4 times 6, does that give me my 48? No. If I take that and I half it, 8 times 6, does that give me 48? Boom, there it is.
Oh. Oh.
Math!
Oh, it was so easy. Oh. I didn't think of it.
Okay. Hey, go away.
Me?
Yeah.
Because I coughed and he was like, hey, go away. It's like, gee.
Hey, not good.
What?
6,
No, sir.
7,
Wait. Wait.
9.
8. Wait, I can't see it.
I think I got it.
8.
Yes. I want to explain it. I think I got it.
Sí, señor.
I want to explain it.
All right,
I want to explain
I'm going to do 8. Don't get mad at me,
Why?
We can't get it.
What do you?
because first I was kind of heated that it was,
I think I got it.
that I'm like, so amazing.
Just go shoulder down.
Now, this says, you guys ready?
Yeah.
An oblique hexagonal prism has a base area of 68 square meters and a lateral, that means slant side, that is 10 radical 2 meters. The lateral side makes an angle of 45 with the horizontal plane containing the base as shown. So,
Should make it move.
I wasn't doing anything.
everybody's looking at you.
Actually, let's go.
So, if this was a right geometric solid, then we would still be using the same formulas, which are the area of the base multiplied by the height, right?
Yep.
And they told us what the area of the base was. They said the area of the base is 68 meters squared. Correct? All I need is a height. If you take a look at this and you examine that, it looks like we have a slant height which is 10 radical 2, and it's parallel to the base. I'm looking for the height. That means that's going to make 90 degrees. And if that's 45, then this is 45, which means I love this triangle because this has to be 10 and that has to be 10, which means the height is 10 meters. Therefore, the volume is 680 meters cubed.
Yes.
There you go.
I like realized this on like the way to the store. I was like, oh, my parents were looking at me and like explain. They're like looking at me like I was speaking Japanese. My dad's like, I'm glad you figured it out.
That's what history does when we talk in the workroom.
Yeah.
What are they talking? What are they saying? What language are they speaking? Math.
I did number 10.
Questions on this one?
Nothing.
No?
I have a question on number 7.
You mean you have a question about number 7? I like that better. That was much more fun. Shout out to Edith.
What is up? Wait, is she watching it?
Yeah, she is.
I don't know. I'm assuming she is. Hi, Edith. Can you say hi? Can't hear you.
Type hi. Type. He made me
Can you type hi?
What did you type? Oh, I can't do it.
Where'd you get this? Did you get what number did you
I can't hear this question. Go ahead.
No, he answered it.
Okay. Awesome. Thank you.
They're preventing me
You guys need to stop as well. You need to cease and desist.
I'm sorry, we're singing.
I still don't really understand what this is.
There is no time for that.
Yes.
Oops, I spelled it wrong.
Abstain.
Abstain.
It means to cease. So
That
then
means-
what does cease mean?
That means to take.
You're saying the same word twice.
So stop and quit. I think you had it on the. Had it right. Question on 7. What's your question about 7?
Well, I'm sorry. I don't even know which one it was. I had it on my paper. Mr. Edith says hi.
Tell her to chat it. Tell her to go on the chat. Is she on my website or is she on the?
She can hear you. I don't know. She just texted back hi.
Oh.
Videos.
Oh, she's on the website so she can't chat.
She's texting me in class.
Alright, anyways, number 7. What about 7? Anybody need 8?
We just did it.
I mean 9?
Yeah.
Okay, cool. You guys ready?
Guys, I think he's having a stroke.
Tickle myself. Oh, did you just do Superstar? Oh, yeah. You guys remember Superstar? Was he like, really?
Yeah. No, because she was like, tickle me Munoz.
Okay, thank you. So for this question, here's what they're telling us. They are saying a right triangular prism. So here's our right triangular prism and a right square prism are given the base of a triangular prism. Okay, so the base of the triangular prism is isosceles right triangle. An isosceles right triangle with a hypotenuse of 6 radical 2. Both solids have a height of 10, and their bases have equal areas. If their bases have equal areas, then Bree?
Wouldn't that be a 45, 45, 90?
Yes. So that means that all the cross sections have the same area. So just like the last question, I'm going to take the area of that square, or that triangle, base times height divided by 2, and I'm going to set that equal to one of the sides squared, because those have to have the same area. Now, as Ricomini pointed out, if this is a right isosceles, then we're going to be working with a right triangle that has 2 angles that are the same. And the only one that is right and isosceles is the 45, 45, 90. And if the hypotenuse is 6 radical 2, then the height is 6 and the base is 6. So you've got 6 times 6 divided by 2 is equal to one of the sides squared. So you've got 3. So the side square is equal to 18. Take the square root of that. Now this is one possible solution I would accept, which is root 18. Or you can take your 18 and break it down with your upside down cake, which would give you side is equal to 3 radical 2. Or of course you could take either one of those, plug it into the calculator, and get the decimal approximation, and you should be good to go. Let's shout. Huh? I can't hear you. What was the question? That's 9. Yes, 9. You had a problem with that problem?
I had a problem with every problem, so.
That's why they call problems.
Mind boggling, right?
No,
I told DeAndre a joke at 6 hour. I was like, you cold? I was like, come in this corner. It's 90 degrees. And then I was like, ha ha, and like nobody laughed.
That's actually
I felt bad
that was good.
and sad.
That's good. I wish I was there. I would have backed you up with lots of laughter.
Yeah.
We'll do some more of those tomorrow. Okay?
I know.
Now that made sense.
Hey, children. The box problem. You were supposed to do a bunch of different boxes where the height just kept getting taller, 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 which reduced the side of the length and the width. And what happens is there's a point where you've got a volume, but as you increase the size, you increase the volume until a certain point where actually the volume starts to decrease. So that's what you were looking for, okay, is what the maximization point for that was. And what we'll do tomorrow, which is actually the last lesson before you take your test, is how to do maximization problems. Okay. What?
That's what's taking it.
No. You're taking Wednesday.
Oh, sorry.
You mean Thursday?
What? Wait, what?
He's waiting for me to catch on.
What's new? Yes!
What if you won't be here Thursday?
Oh, if you're not here Thursday, you have to take your test after school.
What if I won't be here after school?
That's some other day.
Okay.
You'll come back. Well, they always come back.
What if she moves?
You know how much
Then you won't have to worry about it. I'll chase you down to text and be like, get your logged in. Go get the ITI Galileo-online.com. Okay. Just real quick, the maximization problems have to do with quadratic equations. And you guys have already done quadratic equations because you already took algebra 1. So if you are having issues, how is that funny?
What did I do?
So if you've already taken algebra 1, you're expected to already know how to work with quadratic equations because that's what you're going to be working with. Now here's the two deals. quadratic equations look like parabolas, and there's two types. You have those that are smiley. Those are your positive ones, yeah. And what you're looking for is you're going to have, in this case, all you can get is a minimum from that. In our situation, you should have gotten a shape that kind of looks like this. Okay, somehow, because there is a maximum point. You can start to increase to a certain point, which is the maximum, then it'll start to decrease. So that's what you're after right now when you're trying to maximize. You will have negative parabolas, and it has to do with systems. So you take into account the perimeter as well as the area, and then it comes up with some good ideas of how you can maximize what is it you got to do. No. Kind of, sort of, but not really. But we have to hit maximization and minimization. Okay? Okay, everyone say bye to Edith.
Bye, Edith, I love you.
That didn't sound too happy. Bye, Edith.